Okay, number one says when aluminum is heated in oxygen, solid aluminum oxide is formed. Right now, write down for letter A the balanced equation for that reaction. So again, we're on the worksheet titled Stoichiometry number 3. And number one says when aluminum is heated in oxygen, solid aluminum oxide is formed. Recall, in order to do stoichiometry, we have to have a balanced equation. Again, what I wrote up on the board would be my first step. Here's aluminum, here's oxygen that's diatomic, here's the correct formula for aluminum oxide. Then I would balance using coefficients to end up getting a 4 to 3 to 2 ratio. We can very quickly answer letter B, and then I want to talk about this equation a little bit. Letter B says, what type of reaction is this? It is synthesis. Good. Now, let's remember a little over a week ago the glory that is stoichiometry. These coefficients, this 4, 3, and 2, they mean more than just balancing an equation. They are like a recipe. I need 4 parts aluminum for every 3 parts oxygen to make 2 parts aluminum oxide. What we went over last class is the ratio of those could help us solve for something else. For example, if I started with 8 parts aluminum, how much aluminum oxide would be made? Anyone? If I started with, instead of 4 parts aluminum, if I started with 8 parts aluminum, how much aluminum oxide would be made? 4. Notice that this is twice as big as that. Same type of ratio holds true. Well, what if I wanted to make only 1 part aluminum oxide? How much oxygen would I need? Claire? 1.5? Just using the ratio, half as much? You need half as much. That ratio is what stoichiometry is all about. It's the balanced equation coefficient ratio. So, if we look at letter C on this worksheet is a little bit more of a practice problem of this type. Letter C says how many moles of aluminum oxide will be produced if you start with 3.27 moles of aluminum. In stoichiometry, write down what you're given. 3.27 moles of aluminum. Stoichiometry is basically metric conversions ramped up a little bit more. I mean, metric conversions is power of 10. Stoichiometry is based on a balanced equation. So, in this question, it asked us how much aluminum oxide is produced. That means what we want to solve for is on the top of our equation. What we already had is on the bottom, the aluminum. Because just like metric conversions, we need to cancel out aluminum and solve for a new unit. How are the two related? Look at the balanced equation. There are 2 parts aluminum oxide for every 4 parts aluminum. So if I were to solve this, I'd get out my calculator. I'd take 3.27 times 2 divided by 4. Unlike the practice sheet I gave you last time, this gives you 3 sig digs, so I would report with 3 sig digs. So I'm not going to call it 1.635. I'm going to call it 1.64 moles of Al2O3. couple things I want to bring up about this. One is my unit is not just moles, but moles of what? Because this question could have asked you how many grams of oxygen would completely react with 3.27 moles of aluminum. So I want a complete unit when you do stoichiometry. Second thing, again, keep track of what did I start with and then how to set up my conversion. This is what we went over prior to spring break. Using the coefficients to relate one thing to another. In a recipe, if I need 2 tablespoons of butter for every 1 cup of sugar to make 1 dozen cookies, well then what happens if I have 8 tablespoons of butter? How much sugar do I need? How many cookies can I make? Think of the balanced equation like a recipe. Is there questions on letter C? Because if we kind of remember this, we can take it one more step. And that step is shown in letter D on this sheet. Letter D asks, how many grams of aluminum oxide will be produced if you start with 13.6 grams of oxygen? Notice how grams is given to you now. The balanced equation is relating moles of aluminum to moles of oxygen to make moles of aluminum oxide. Those coefficients do not relate grams of one thing to grams of another because every element has a different mass. Just like there's a different mass for 2 tablespoons of butter versus a cup of sugar. We can't relate the two based upon mass necessarily. So what makes this question different is it gave me 13.6 grams of oxygen. It wants me to solve for grams of the aluminum oxide. But that step I have on the board right now, this right here, only works to convert from moles to moles. Balanced equation coefficients do not work for mass because every element has a different mass. Which is why, when we start this problem right here, we have to go way back to first semester and convert our grams into moles. How many grams should be on the bottom? 16? Because it's oxygen? Kyla? It's O2. So let's go 32 grams in the bottom. So, step number 1. Take our 13.6 grams divided by 32. So actually what I just did was a mole conversion. Bless you. But now that we are in moles, now we can use the coefficients to go from moles of one thing to moles of another. I'll see if I can fit that conversion right here on the end. I want to solve for the aluminum oxide, it says in the problem. I have oxygen. That's a 2 to 3 ratio. And what I'm going to do is I'm going to put that answer right below my start to kind of continue this problem. So if I multiply by 2, divide by 3, I'll hold on to 3 sig digs. Perhaps now you can see the importance of labeling not only moles or grams, but of what. Because in stoichiometry, we have to keep track of what thing are we starting with, what thing are we ending with. My first step was converting my grams into moles using the periodic table, something that you've been doing for at least 4 months now. Second step was using the balanced equation coefficients to convert from one thing to another, something that you learned last week. My final step, now I'm in moles of aluminum oxide, I want to get the grams. Let's use the periodic table again, just like we've been doing for 4 months. I have 2 aluminums plus 3 oxygens from the periodic table. I add all that up, and I'll help you out with that, 101.98. This gives me a final answer of 28.9 grams of Al2O3. So what this says is if I start with 13.6 grams of oxygen, I would produce 28.9 grams of Al2O3. Stoichiometry allows us to start with the mass of something and solve for the mass of something else. Notice how you took the mass of your aluminum foil at the start of the lab. Well, I bet you could solve for the mass of the solid that you're creating at the end of the lab. For the most part, it is a 3-step process. Convert your grams into moles like I did in step 1. Use the balanced equation to convert from one thing to another in my step 2. Convert back to grams in step 3. Stoichiometry is introducing step number 2. You've known steps 1 and 3 convert back and forth between moles and grams all year long. But now we have to put it all together. Okay, chemistry isn't difficult because the amount, sort of the difficulty of the math that we do, it's the knowing which one to use and when. Because it's just 3 separate conversions. Question with stoichiometry. And notice how it always starts with the letter A of writing the balanced equation. So here we go. Number 2 says, aqueous ammonium hydroxide reacts with copper 2 nitrate solution to form soluble ammonium nitrate and copper 2 hydroxide precipitate. Boy, the author of this question is pretty nice. They already told you the 2 products. You didn't even have to look at your solubility table. Again, to speed this along a little bit, ammonium hydroxide is NH4OH. Copper 2 nitrate, CuNO3 yields. The first product is ammonium nitrate. I'm sorry that I'm running out of room, so I'm going to write my other product below, which is the copper 2 hydroxide. That's a solid. Again, you might have to use your polyatomic ion sheet when you're doing this to help figure out which one is which. From there, though, you do need to balance the equation. I'll even write that in red because stoichiometry, those coefficients are really important. It looks like I have 2 nitrates on the left. I need 2 nitrates on the right, but that now gave me 2 ammoniums. So I need 2 there. I have 2 hydroxides on both sides. This equation is balanced. Don't be alarmed if an equation balances easily. There's nothing wrong with that. By the way, letter B, what type of reaction is this? Double displacement. Yeah. I would like to skip letter C on this worksheet, ladies and gentlemen. Letter C is converting from moles of one thing to moles of another. That's using the coefficients. It's a 1-step problem. I would prefer to do letter D, where it's asking you to solve for grams, and it gave you grams. That's a 3-step problem that I just introduced today. I'd like to give you one more practice with that. So let's look at letter D on this worksheet. It says how many grams of ammonium hydroxide were consumed if 87.9 grams of copper 2 hydroxide were produced. I always immediately write down what's given to me. 87.9 grams of copper 2 hydroxide. This question asks how many grams of the ammonium hydroxide were consumed. So we're trying to figure out the ammonium hydroxide. We're trying to figure out this guy right here. Step number 1. If we start with grams, we have to convert to moles. Just like you were taught first semester. 1 mole on the top, grams on the bottom, and then I look at my periodic table. For example, copper is 63.55, oxygen is 16, hydrogen's 1.01. However, there's 2 of both of those. If I add up all of that, I get what's called the molar mass. We're going to call it 97.57. If I solve for this, it's going to give me a number of moles. I get 0.901. I'm going to rewrite that number right here. Step 2. I have moles of one thing. I want to solve for moles of another. What do I want to get to? I want to get to the ammonium nitrate. The NH4, the ammonium hydroxide, NH4OH, from the CuOH2. If I look back at my balanced equation, there's 2 ammonium hydroxides for every 1 copper 2 hydroxide. So that means I multiply by 2. Sig digs wise, that should give me 1.80 moles of NH4OH. And again, because I don't have a lot of space, I'm going to rewrite this. Perhaps you're just working left to right. Final step. I want to go from moles of ammonium hydroxide to grams of ammonium hydroxide, which means grams is on the top of my conversion, moles is on the bottom. If I add up the mass of 1 nitrogen, 4 hydrogens, 1 oxygen, and 1 hydrogen, that would give me a conversion of, I think I have 35.05 written down. Which would give me 63.1 grams of ammonium hydroxide as my final answer. Stoichiometry, typically for us in this class, because there's actually a lot more applications that we don't get into Chem 1, but typically is a 3-step problem for you guys. True stoichiometry is just the balanced equation step 2, but we measure things in grams. You did it in the scale today. Next class, you're going to come back and measure out that solid that you have in your filter in grams. So if we measure in grams and we solve for things in grams, that's what we're able to do. I want to show you one more thing before I'm done with this for the day. And that is, boy, did this problem take up a lot of space. I write this a much more abbreviated version. I still show my work, but I'm able to not take up as much space. So I want to show you how I would set up this problem. I write down what I'm given. My first step is I convert to moles from grams, and again, that was the 97.57 number. Instead of me hitting equals and giving you a value, I know what I just did is I canceled out grams. And now I have moles of copper 2 hydroxide. I go straight into my next conversion. And I wanted to solve for the ammonium hydroxide from the copper hydroxide. Because now, look, I have copper hydroxide on the top and on the bottom. They cancel out. I'm left with moles of ammonium hydroxide. Again, I don't hit equals. I do my third conversion. So you know how many grams per mole that is? Again, that number that I had above here was 35.05. Because then moles on the top and the bottom cancel out. My final unit would be grams of ammonium hydroxide. So what I would do then is I'd take this 87.9 divided by 97.57 times 2 times 35.05. I get the exact same answer that you would, although I didn't round off in between steps, so that might actually help my accuracy a little bit. But if you are comfortable with stoichiometry, I would suggest setting up all your conversions at once and then typing into your calculator. For those of you who are still a little, I'm not sure, the three-step process, convert to moles, stoich, convert to grams, might be the way to go. But truly, ladies and gentlemen, this is stoich for you guys. There's no more for me to show over the next couple class periods other than this. It's just a matter of us practicing it.